In this video, we're going to see how we can develop interval estimation for the population proportion. And for this, we're going to use data file WomenGolf. Building upon the sampling distribution for sample proportion, we can find the final formula for the interval estimate of a population proportion. I'm not going to go through the details of how we got here, but it's very important to understand this formula, be able to interpret this, and be able to actually use it for finding the interval estimate, for finding the upper and lower limit. So the ingredients that we have here, we have the sample proportion plus and minus a margin of error. This whole thing at the right side of this formula is called margin of error. Now, margin of error for population proportion. P bar plus margin of error gives us the upper limit. P bar minus margin of error gives us lower limit of the interval. Now, the margin of error is z value, z half of alpha, times the standard error. And standard error for population proportion would be square root of P bar times 1 minus P bar divided by N. Now, the whole thing, you need to take the square root of the whole thing, all right? And then again, alpha is the level of significance, is the chance that the interval that you're generating does not contain the population proportion of P, all right? Okay, so this is the formula. Now let's go ahead and apply this using one example, the WomenGolf. In this example, we want to find the 95% interval estimate for the population proportion of female golfers in the United States. So we're looking for 95% confidence interval for the proportion of female golfers in the US, in the United States. All right. So we're trying to understand how many percent of all the golfers in the United States are female. In order to understand that, we took a sample of size 400, a sample of 400 golfers, and we recorded their gender. So we have the gender information of 400 golfers in the United States, randomly selected. Now, we are going to apply the formula for the population proportion in order to get the confidence interval. So I'm just going to go ahead and find all those ingredients that we had. So the main item would be P bar, which is the sample proportion of female golfer. For P bar, we need to find the sample size first, and we also need to find the count of females, and then when we divide the count of females by the sample size, it's going to give us the proportion of female golfers. All right, so I'm just going to first, we're going to get the sample size, and we also are going to get the, I'm just going to record the response of interest, or I mean, this is basically the gender of interest, which is female. So I'm just going to basically compute them as I'm writing. All right, so the sample size is going to be count A of my sample, And I just need to take only the values, count A, or you can just type 400. You know that the sample size is 400, all right? What is the gender or the gender of interest or the response of interest in this case? That would be a female. We're trying to count the number of females, all right? So count of interest or count of females simply count if is female. Count in column A if it's female. So count if the range. So we're going to count all the cells in column A, and then criteria is the criterion that we're looking for would be the word female. So this would give us the count of female in our sample. And with this, we can go ahead and find the sample proportion, P bar. I mean, you can write P bar if you would like. And that would be 100 divided by 400. Out of 400 people, out of 400 golfers, 100 of them are female. All right, so sample proportion here is 25%. So this would give us the point estimate. All right, we're trying to find the margin of error. For the margin of error, we need two ingredients. We need the z value and we need the margin of error. I'm just going to go with the z value first. So we have the confidence coefficient. We're given with the confidence coefficient. You don't need to worry about this one. It's 95%. All right, I just typed 95%. And then level of significance would be 1 minus confidence coefficient. If confidence coefficient is 99%, your level of significance would be 1%, or 95%, 5%. All right. And now z value for alpha, we're looking for z half of alpha. For this, we're going to use this function, normal, standard, inverse. So this is the function that we're using, normal, standard, inverse. And then the probability is going to be 1 minus half of alpha. This is what we are trying to get. So we're giving the area below the curve to the left side, and that would be 1 minus half of alpha. When we do that, that would give us basically the z value. Now, I got the z value. I have the p bar. For the margin of error, we have the z value. We still need to get the margin of error. For the margin of error, we need to get the standard error first. And then when we have the standard error, we can easily multiply z value with the standard error and get the margin of error. So standard error would be QRT square root of P bar times parenthesis 1 minus P bar divided by sample size 400. This is like the parentheses are important where you're putting them. So this is P bar. So everything should be in parentheses, the whole thing. P bar times 1 minus P bar should be in parentheses, and then divided by sample size n. If you misplace these parentheses, the result might be completely inaccurate. So this is it. So standard error. And then margin of error is going to be simply z value times standard error. So we got the margin of error. we have the sample proportion. We're almost there. Point estimate, upper limit, lower limit. So point estimate is going to be for the population proportion of female golfer is going to be 0.25%. 0.25% is the point estimate. The lower limit would be point estimate minus margin of error. Upper limit would be point estimate plus margin of error. All right, so now we have 95% confidence interval for the proportion of female golfers in the United States, right? So now I'm not done yet, so I should say with 95% confidence, the proportion of female golfers in the United States, in the country, is between almost 21% and 29%, 20 or 20.7% and 29.2%. So there is 95% confidence that the proportion of female golfer is between these two numbers. And there is again 5% chance that you are wrong about this, and the proportion is either, with 5% chance, the proportion is either below this number or above this number.